Okay, today we talk about binomial distribution and Pascal's triangle. So take out your video lesson notes and let's get started. It's a long lesson. So we have a bunch of binomials. The first one's raised to the 0 power, and we know that anything raised to the 0 power is 1, even a binomial. We also know that anything raised to the first power stays the same. So x plus y to the first stays x plus y. Next we have x plus y squared. Well, when we square a number, we multiply it by itself. So that's really x plus y times x plus y. And then we get to practice our double distributing skills. We get x squared plus 1xy plus another xy plus y squared. Combine like terms in the middle and get x squared plus 2xy plus y squared. Okay, that's all stuff we've done before. Well, what if we want to know what x plus y cubed is? Well, it's really x plus y times x plus y squared. And now we already have the expansion for x plus y squared from our previous problem. So what we're going to do is multiply x plus y times x squared plus 2xy plus y squared. Again, double distribute. Now, if you're really good at this, feel free to fast forward. This gets really boring to listen to. And what I do as these get longer is I line up my like terms when I move over to be multiplying by y so that I can see what's going on and make fewer mistakes finding like terms. Thanks. So I line up my like terms, I combine my like terms, and I get x cubed plus 3x squared y plus 3xy squared plus y cubed. Okay, so we're going to follow the similar process with x plus y to the fourth. That's really x plus y times x plus y cubed. I have x plus y cubed expanded from earlier, and so I'm going to take x plus y and multiply it by x cubed plus 3x squared y plus 3xy squared plus y cubed. And again, lots of distributing. Feel free to fast forward. This is really boring to listen to, whether it's in class or on video. Notice that we're following the same pattern, lining up like terms all along. Math's about patterns. The sooner you recognize that, the faster this will go. So my final answer, x plus y to the fourth expanded, is x to the fourth plus 4x cubed y plus 6x squared y squared plus 4xy cubed plus y to the fourth. Now, this is getting really old really fast. I'm getting tired of all this distributing. X plus y to the fifth is x plus y times x plus y to the fourth. So I would need to distribute x plus y through that previous answer. I stopped having fun a little while ago, and I imagine you did as well. So part of the point of today's lesson is to have you stop having fun. I need you to say, you know what, there's got to be a better way. So the next thing on your video notes is to remind you that as the number of terms increases, that expansion, it's obviously a lot less fun to do that by hand. You can always fall back on distributing if necessary, but it's a time waster and it's boring and you're likely to make mistakes. So another option we have is this general expression for expanding a binomial. That expression, a plus b to the n, is equal to the sum of all numbers r equals 0 to n of ncr times a, the first term, to the n minus 1 r, times b, the second term, raised to the r. This is given to you on your formula sheet. You do not need to memorize it, and there it is. Also on your formula sheet is that summation written out for you. So if you don't remember what summation means, it's given you that definition above it. So I'm not sure why they gave it to you in that order, it doesn't matter, but they mean the same thing. So what we're going to do is practice one using that formula, and you can decide if you'd rather distribute a lot or learn how to use the formula and your inspire. So here we go. We're going to use that to write the expansion x plus y to the 8th. Well, trying to get things to work in that formula. Here a is really x, my first term. My second term b is really y. And the exponent on the problem is 8. So I define those off to the side in case I start to feel lost. So I'm going to find the sum of all r equals 0 to n, which in this case is 8. So I'm going to plug in numbers r from 0 to 8. I'm going to start with that 8, n, c, r, in this case 0. I'm going to multiply that by its first term, x. And that x goes to the n minus r. 8 minus 0 is 8. And I'm actually showing you that subtraction for this problem so you can see where everything came from. Times your second term raised to the r, which in this case is 0. Now sum means add, so I'm going to add to that. Next I have 8c1. The number after 0 is 1. I take my first term x and raise it to the 8 minus 1. r is now 1. And then take y to the first. And I continue this until I get to r equals 8. So I have 8c2 times, sorry, I have to zoom out so you're going to be able to see all this. I have 8c2 times x, the first term, to the 8 minus 2, times y, the second term, squared, plus 8c3 times x to the 8 minus 3 times y to the third, plus 8c4 times x to the 8 minus 4 times y to the fourth, plus 8c5 times x to the 8 minus 5 times y to the fifth, plus 8c6 times x to the 8 minus 6 times y to the sixth, plus 8c7 times x to the 8 minus 7, weird pause here, times y to the 7th, plus 8c8 times x to the 8 minus 8 times y to the 8. And then you need to clean it up after I finish writing this last expression. So this isn't a lot better either, because now I have to do all those combinations in my calculator. I know, just because I know, that 8c0, any number c0 is 1, times x to the 8th, and y to the 0 is 1, so I'm going to leave that alone. 8c1, any number c1 is that number, so 8 times x to the 7th y, plus, now I need to go to my calculator and figure out 8c2. And what I did to save time is I punched in actually all the combinations at once. Just by copying and pasting, once I've gotten one, I can just keep changing 8c2 to 3, to 4, to 5, all the way up to 8. So I don't have to keep flipping back and forth. You don't have to do that ever. You may not want to, but I needed to make sure that the video was short enough. So that's why I'm doing them all at once right now. Alright, so once I've figured out all my combinations, I can go back in and plug in and simplify that great big expansion that I just did using my formula. So now I have 28 x to the 6th y squared plus 56 x to the 5th y cubed plus 70 x to the fourth y to the fourth plus 56 x cubed y to the fifth plus 28 x squared y to the sixth plus 8 x y to the seventh plus y to the eighth. And there's that expansion. Again, not very pretty, but probably still better than doing all the distributing and combining like terms and potentially making mistakes. Let's look at the coefficients of my expansions. X plus y to the 0, I got a 1. Remember, a coefficient is the number in front of a variable. The coefficients of my expansion x plus y are both 1s. Copy these down on the back of your notes sheet in the way I am. X plus y squared has coefficients 1, 2, and 1. So write them down in the same way I am. You'll understand why in a minute. X plus y cubed has coefficients 1, 3, 3, 1. Again, write them down the way I am. The coefficients on x plus y to the fourth expanded are 1, 4, 6, 4, and 1. This triangle is called Pascal's triangle, and I get every term by adding the 2 above it. And we always start and end with 1. So I can find the next row, start with 1, 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5, and end with 1. You can do that the same for the next row. Start with 1, 1 plus 5 is 6, 5 plus 10 is 15, 10 plus 10 is 20, 10 plus 5 is 15, 5 plus 1 is 6, and end in 1. If you know Pascal's triangle, those are the coefficients for any expansion. So if we want to go back up in our notes, well, first of all, let's look at also the pattern with the variables. I start with my x's on 8, and it goes down by 1 each time. And my y's start at an exponent of 0 and go up by 1 each time. So if I put together Pascal's triangle and that pattern on the exponents, then I can expand x plus y to the fifth faster. I find the fifth row, or the row with a 5 in the beginning of it. It's really the 6th row because we call the first row the 0th row. I copy those coefficients down, expanded. So I have 1, 5, 10, 10, 5, and 1. Once I have the coefficients, I follow the pattern, and I start with x to the fifth, and I decrease the exponent on it by 1 each time. So x to the fourth, x cubed, x squared, x to the first, and x to the 0. It's not bad to write that to begin with and then clean it up later. My y starts with an exponent of 0 and goes up by 1 each time. Y to the first, y squared, y cubed, y to the fourth, and finally y to the fifth. And then I clean that up. I don't need to see coefficients of 1, and I know that anything to the 0 is 1. So I end up with x to the fifth plus 5x to the fourth y plus 10x cubed y squared plus 10x squared y cubed plus 5xy to the fourth plus y to the fifth. There's my expansion. It's a lot faster using Pascal and patterns than it is distributing or using the formula. But you do have 3 choices. So you need to do what's best for you. In summary, there are 3 ways to expand binomials. You can do what we've always done and just keep distributing, distributing, distributing. My concerns with that are if you're asked to expand something like xy to the 18th, you'd be in trouble. You can use your formula on the formula sheet, where I suggest Pascal's triangle and the general expansion pattern. That's it. We'll practice lots more in class. Have a great night.